Good morning. My name is Kaushik, and today my topic in Linux programming is about zombie process with an example. So, coming to the introduction, a zombie process is a process whose execution is completed, but it still has an entry in the process table. Zombie processes usually occur for child process, as a parent process still needs to read its child exit status. Once this is done using the wait system call, the zombie process is eliminated from the process table. This is known as reaping the zombie process, a diagram that demonstrates the creation and termination of a zombie process given as follows. So if parent process is put into wait, it will be in parent process. And if a parent if a parent process by using fork, it becomes child process. And after execution, it uh, it still remains a child process. And as it exits, it becomes a zombie process. So zombie process working in an operating system, a zombie process works in the following way. When a process ends with exit, all the memory and resources associated with it are deallocated, so the other processes can use them. So since the process is new, it is admitted and to be ready, and it can. So there are three ways the ready stated process can go. It can either uh, start running, or it can either start waiting. It waits because of like uh, it it waits due to input output completion or event completion. It can also be interrupted when it started when the process is running, and after running, if the process is completed, it exits, and from there it terminates. And after it is terminated, it waits to be completely terminated. So coming to the working of zombie process, however, the process entries in the process table remains. The parent can read the child's exit status by executing the wait system call, where the zombie is removed. The wait call may be executed in sequential code, but it is commonly executed in a handler for the SIG child signal, which the parent receives whenever a child has died. After the zombie is removed, it process identifier PID and entry in the wait in the process table can be then reused. However, if a parent fails to call wait, the zombie will be left in the process table, causing a resource leak. In some situations, this may be desirable, and the parent process which wishes to continue holding the resource. For example, if the parent creates another child process, it will not be allocated to the same PID, which means the same process identifier. The following special case applies to modern Unix-like systems if the parent explicitly ignores signal child command by setting its handler to SIG underscore IGN rather than simply ignoring the signal by default, or has an SA underscore no child wait flag set. All child exit status information will be discarded and no zombie processes will be left. Zombies can be identified in the output from the Unix ps command by the presence of a Z in the stat column. Zombies that exist for more than a short time typically indicate a bug in the parent program or just an uncommon decision to not reap children. If the parent program is no longer running, zombie processes typically indicate a bug in the operating system. As with other resource leaks, the presence of a few zombies is not worrying in it, but may indicate a problem that would grow serious under heavier loads. Since there is no memory allocated to zombie processes, the only system memory usage is for the process table entry itself. The primary concern with many zombies is not running out of memory, but rather out of process table entries and concretely process ID numbers. Using the kill command, the signal can be sent to the parent manually to remove zombies from a system. If the parent process still refuses to read the zombie and if it would be fine to terminate the parent process, the next step can be to remove the parent process. When a process loses its parent, initialize become its init becomes its new parent. Init periodically execute the wait system call to reap any zombie with init as a parent. So the process coming to the process states, Linux maintains a process table of all the processes running along with their states. Let's briefly overview the various process states running. So these are the four process states which are running, waiting, stopped, and zombie. So running means These processes are currently running or runnable. For waiting is these are processes that are waiting for an event or a resource. The wait can either be an interruptible sleep or an uninterruptible sleep. Stopped. We can stop a Linux process by sending an appropriate signal. Zombie. When a process finishes its task, it releases the system resources it was using and cleans up its memory. However, its entry from the process table is not removed, and its status is set as exit/zombie. We'll gain a better understanding of the concept of zombie processes in the next subsection. Zombie process creation. When a process completes its job, the Linux kernel notifies the exiting process's parent by sending the SIG child signal. The parent that then executes the wait system call to read the status of the child process and reads its exit code. This also cleans up the entry of the child process from the process table and hence the process finishes. However, if a parent process isn't programmed to execute the wait system call on the creation of the project process, proper cleanup doesn't happen. In such cases, the parent process cannot monitor the child changes of the child processes and eventually it ignores the signal child signal. So this causes the zombie state of a finished processes to stay in the process table and hence it appears in the process list as a zombie process. Another case of interest in which a parent process is unable to handle or receive the strict signal from the child process, such cases are also lead to zombie creation. So killing zombie process. Zombie processes can be killed by sending the signal to the parent using the kill command. The signal informs the parent process to clean up the zombie process using the wait system call. The signal is set with the kill command. It is demonstrated as follows. So this is the command which we use to kill the zombie process by the parent processes. In the above command, the PID is the process ID of the parent process. Thank you.